Okay, welcome back to another section of simultaneous equation. We want to look at the graphical method. The graphical method. Remember, in the previous class, we've dealt with elimination method, substitution method, and elimination substitution method. So let's look at the graphical method today. In this method, I'll quickly give us a short form of dealing with it without much stress. So we'll be looking at the different equations. We'll be looking at the different equations to bring out the coordinates. So in this equation, we'll be dealing with coordinates of x and y. Coordinates of x and y. So let's start with equation 1. Equation 1. From equation 1, 2x minus y is equal to 8. From equation 1, 2x minus y is equal to 8. If I close this part of the equation, this figure, this number, this variable, what you see there is minus y is equal to 8. Minus y is equal to 8. That's what we have on the board there. So I should be writing it in this form. 2x is closed. Minus y is equal to 8. Therefore, y is equal to minus 8. Y is equal to minus 8. So the coordinate of y is minus 8. Now, still on that same equation, if I close minus y, what you'll be seeing is 2x is equal to 8. If I close minus y, what you see is 2x is equal to 8. So if I should write it in this form, 2x a box is equal to 8. Alright, therefore, x alone will be equal to 8 over 2, which is 4. So the coordinate of x is 4. So the coordinates we are going to have, x and y, will be 4 and minus 8. That is from equation 1. The coordinates that we have are 4 and minus 8. Your coordinates are always x and y. X comes before the y. So we have 4 for x and minus 8 for y. We are done with equation 1. So we'll now go to equation 2 and also find the coordinates of equation 2. Equation 2 is 3x plus y is equal to 17. Now, if I close this part, what you can see is plus y is equal to 17. Plus y is equal to 17. So I'm supposed to write in this form, a box closed, plus y is equal to 17. Therefore, y is equal to 17. So the coordinate of y in equation 2 is 17. Still on equation 2, if I close the y part, what you could see is 3x is equal to 17. 3x is equal to 17. So I'm to write it in this form. 3x, a box, is equal to 17. So we have 3x is equal to 17. X alone will be 17 divided by 3, which is 3 in 17 is 5. Remember 2. Add 0 to the 2, becoming 20. 3 in 20 is 6. So in decimal form, 3 into 17 is 5.6. 5.6. I can also just estimate that to be 5 if I wish. So x is 5.6. So the coordinates of x and y in equation 2 are 5.6 and 17. 5.6 and 17, or let me just say by approximations, 5 and 17. That is what we wish to have. But it's better we use 5.6 anyway. So let's just use our 5.6 because we're going to put it in the graph. 5.6. So the coordinates for equation 1 are 4 minus 8, and the coordinates for equation 2 are 5.6 and 17. We're going to put this in our graph now. We're going to put these coordinates in our graph, please. I want to believe you understood how we got 4 and minus 8, 5.6 and 17 from equation 1 and equation 2. Here's equation 1 that we got the coordinates from, and here's equation 2 that we got the coordinates from. So I want to put that in our graph right now. So I'm going to draw a graph Usually your graph book has on the vertical side about 24 or so, on the horizontal side about 18 or 20 or so. But the board here will not contain that aspect. So let me just sketch a graph and give us a scale that will help us understand that we are sketching a graph. Yes. So I'll draw a graph first. Let me draw the vertical line. Let me draw the vertical line. You need to be careful when doing this in your book also. Draw a vertical line and write out the different part of the graph. Let me draw a vertical line. I will not draw it to the down part of it. Let me just indicate there are 5 small boxes in the graph. So we have for 1 centimeter, 1 centimeter is equal to 5 boxes. That makes it on your graph book. So we have, let me use these lines as the boxes. 1, 2, 3, 4, 5. A longer line. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So, for us to get the horizontal line, we will need to first of all create spaces for the vertical line to fit in the y-axis. For you to get your horizontal line, which is the x-axis, you view the y-axis. Now the highest number on the y-axis is 17. Is 17. If you use 1 centimeter, this box is 1 centimeter. If you use 1 centimeter to 1 unit, your 17 will not enter. That will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And don't forget, we also have a negative number for y, which is minus 8. So let me use a scale quickly here without wasting much of our time. 2 centimeter or 5 units. 2 centimeter or 5, that is for 5, that is 1 centimeter, 2, I'll write 5. 1, 2, I'll write 10. 1, 2, I'll write 15. 1, 2, I'll write 20. 1, 2, I'll write 25 to create extra space. Then at this 25, I can draw my horizontal line. At this 25, I can draw my horizontal line because the next space will contain the minus 8. The next space will contain the minus 8. So I'm just doing this quickly for us to have a graph drawn. So I want to draw my horizontal line. I want to draw my horizontal line. That is it. That is the x-axis. So here's my x-axis and here's my y-axis. The point where the two, let me count on this first. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. For the negative x, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. X has no negative number. We have 5.6 and 4. But y has a negative number. So the point where the x and the y axis meet is called the point of origin. We are going to be having a class on graph, but let me just chip in some little idea here. So, and that is always 0. So here's a 0. I want to use a scale of 2 centimeter is equal to 5 units on y-axis. That will be 0, 1, 2, 5, 1, 2, 10, 1, 2, 15, 1, 2, 20. 17 will enter here now. 1, 2, minus 5, 1, 2, minus 10, minus 8 will enter here. Then for x-axis, 1, 2, 3, 4, 5, 6, 7. The highest number for x-axis that is positive is 5.6, and there's no negative value for x-axis. So I can just use the scale of 1 centimeter is equal to 1 unit on x-axis. That is 1 centimeter will be 1, 2, 3, 4, 5, 6 minus 1. There's no negative number for x anyway. Now, after having this done, we want to draw the lines of each of the equation. Equation 1 is 2x minus y is equal to 8, and the coordinate of that equation, let me write equation 1 coordinate here, are 4 minus 8. Equation 2 are 5.6 and 17. So let's start. Equation 1, x is 4. You go to where you add x to be 4 and use asterisk there, or you can use circle dot. This is circle dot. Y is minus 4 minus 8. Minus 8 should be here. If here is 5 and here is minus 10 minus 5, minus 8 should be close to somewhere here. Circle dot is you put a dot and circle it. That is circle dot. Either you use the word, you use the coordinate point asterisk, or you use the circle dot. Now you can use the asterisk in the both sides or circle dot in the both sides. Now let's draw that line. You take your ruler and place on the 2 coordinate points. They should touch the ruler properly. Look at it. Then draw the line as long as you can do. Draw it. That is the first line. That is the first line, which is equation 2x minus y is equal to 8. We're done with that. Now we're going to draw the second line also. The coordinate of the second equations are 5.6 and 17. So you go to where you have y is 17. If here is 15 and here is 20, 17 should be at this point, if I'm right, at this point. I will teach you how to know the dimensions of each of these small points in a graph when we are doing graph. So here is 17. Then here will be 5.6. Here is 5, here is 6. 5.6 should be somewhere here. You can see that. Now take your ruler and join the 2 coordinate points. Look at them. This. I hope you're following this class properly. Join the 2 coordinate points properly and draw as long as you can draw. Good. That is the second equation. Equation 3x plus y is equal to 17. Now go to the point where the 2 lines are meeting. This is the point. Read down for x. That is 5. X is equal to 5. Read at the opposite side towards the direction of y. Look at it. You can see that. Carefully use your rulers to do this job so you have the right reading. Asterisk it. Use your point machine, imaginary dots. That should be 2. Y is equal to 2. So you can see that if you solve the 2 equations here, you have, using the graphical method, you have x is equal to 5 and y is equal to 2. This is how you solve using the graphical method. This is how you solve simultaneous equation using the graphical method. And you can see from our sketch graph here, we're able to get y to be 2 and x to be 5, which was the answer we got in the previous class. So go through the class and ensure you get the best out from it. See you.